discussing about function, define function and different types of functions. Now here different types of functions, namely first one is, you know what is that, one function. One function. Another name of one function is injective function. Another name of one is injective function. Type number 2, onto function. Another name of onto function is surjective function. Remember, another name is surjective function. Type number 3, bijection. Bi means to, bijection. Type number 4, inverse function. Inverse function or invertible function. Type number 5, composite function. Composite function. So there are 5 important different types of functions, namely one function, onto function, bijection, inverse function, composite function. Okay, now let us discuss about one by one. So already first one is discussed yesterday. Video first one is discussed my daily. Okay, I will repeat once again. So first one is one function. Just to recall. So one function. Another name of one is injective. One. So definition. One element here, one image related to. So define one function. Remember, a function f from a to b is said to be one function if different elements of a set will have different images in the second set. All the elements of a set will have different images in the second set. Or in other words, a function f from a to b is said to be one if in general image of x1 is equal to image of x2, that is f of x1 is equal to f of x2, implies elements must be equal, x1 is equal to x2. Now for example, verify the function f from r to r defined by, say f of x is equal to 3 plus 4x is 1 r0. You can apply that definition. Now take f of x1 is equal to f of x2. Okay. Now to prove that x1 is equal to x2. Now since f of x value 3 plus 4x, f of x1 replace x by x1. 3 plus 4x1 is equal to 3 plus 4x2. Right? Simplify. This implies 3 plus 4x1 minus 3 minus 4x2 is equal to 0. Take equal on right side. Okay. Now plus 3 minus 3 cancel. So that 4x1 minus 4x2 is equal to 0. Or 4x1 is equal to 4x2. Divide by 4. x1 is equal to x2. Therefore, the given function is one function. A function f from a to b is said to be one if in general image of x1 is equal to image of x2 implies x1 is equal to x2. One element here, one image related to one element here, one image is called, that is known as one function. Okay, another name of one function is injective function. Okay, now second type number 2, that is onto function. Define onto function. Another name of onto is surjective function. Another name of onto is surjective function. So remember, a function f from a to b is said to be onto function. Nodi onto yavagagutte if in general for every Greek symbol, for all the elements, say in general one belongs to set B. Okay, take one element, say in general one belongs to codomain B. There exists, this is notation for there exists, Greek symbol. Okay, there exists its image in the set A. That image element by taking, say in general, say x belongs to set A, such that, this is notation for such that Greek symbol. Remember, image of the function x, f of x is equal to 1, that y belongs to set B. This condition is satisfied, then it is said to be onto function. Another name of onto function is surjective function. Remember, a function f from A to B is said to be onto if for every element, in general say y belongs to set B, codomain B, there exists this image in the set domain A such that range of the function image of x is equal to 1, that y belongs to codomain, that is known as onto function. So now here the above statement is nothing but codomain is equal to, remember that condition, if codomain is equal to range of the function, if this condition is satisfied, then it is said to be onto function. Okay, now take one simple example. Now here f is a function from, or first to take the Venn diagram. So by using Venn diagram, identify is it onto function or not. F is a function from A to B. A is a set consisting of 4 elements A, B, C, D. B is a set consisting of 4 elements 1, 2, 3, 4. Now verify is it 1, 1 function as well as onto function. Check it. Clearly it is 1, 1 function as well as onto. Onto definition, for all y belongs to codomain B. In the codomain B containing how many elements? 4 elements, namely 1, 2, 3, 4. Okay, y and yadu, y value 1 irbodu, 2 irbodu, 3 irbodu, 4 irbodu. For all the elements in the set B, B set ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆಗಿರಬೇಕು. B ದಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆಗಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ that is known as onto function. Take one by one. Say 1 belongs to set B. Take y value is 1. 1 belongs to B. There exists its image is D, belongs to set A, such that f of D, here image of A is equal to 3, image of B is 2, image of C is 4, and image of D is 1. So for all 1 belongs to B, there exists its image in the set A, that element is D, belongs to set A, such that f of D is equal to 1, that 1 belongs to set B, therefore it is onto. Take another number, 2 total image ಇದೆ, 3 total image ಇದೆ, 4 image ಇದೆ. So B set ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆಗಿತ್ತು ಅಂದ್ರೆ that is known as onto function. Here domain is A, B, C, D, codomain is B set 1, 2, 3, 4. What is range? Range is also 1, 2, 3, 4. So codomain is equal to range, codomain ಮತ್ತು range ಎರಡು equal ಆಗಿತ್ತು, then it is said to be onto function. Clearly this example is onto function. What are this? Another example, verify, identify whether is it onto function or not. A set A, B, C, D, B set 1, 2, 3, 4, 5. Now identify, is it onto function? No. Why? Because if you take the element 1 belongs to set B, there exists its image. This image ಏನಾದರೂ A set ಅಲ್ಲಿ ಇದೆನಾ? ಇಲ್ಲ. There does not exist its image in the set A. ಇದು image A set ಅಲ್ಲಿ ಇಲ್ಲ. So it is not onto. B ದಲ್ಲಿ ಯಾವ ಎಲಿಮೆಂಟ್ ಉಳಿಬಾರದು, ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಇಮೇಜಸ್ ಇರಬೇಕು. A ದಲ್ಲಿ ಕೂಡ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆಗಿರಬೇಕು, B ದಲ್ಲಿ ಕೂಡ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆಗಿರಬೇಕು. ಈಗ ಇದು onto ಆಗೋದಿಲ್ಲ, because codomain is not equal to range. Because domain is A, B, C, D, codomain is 1, 2, 3, 4, 5. Codomain is 1, 2, 3, 4, 5. Correct? Codomain set B namely 1, 2, 3, 4, 5. That is nothing but set B. Okay. What is range? Range ಏನಾಗುತ್ತೆ ನೋಡಿ, range ಅಂದ್ರೆ ಯಾವ ತಗೋಬೇಕು? Images. ಯಾವ್ದಾದ್ರು image ಇದೆ? 2 ಇದೆ, 3 ಇದೆ, 4 ಇದೆ, 5 ಇದೆ. So range is 2, 3, 4, 5. Is it codomain is equal to range? ಎರಡು equal ಆಗಿದೆವಾ? No. Here codomain is not equal to range. Codomain is not equal to range. Therefore it is not onto function. Is it 1, 1 function? Yes, it is 1, 1 because different elements of a set will have different images. 1, 1, one element one image ಇದೆ. It is clearly 1, 1, but it is not onto function. Here another example. F is a function from set of natural number to natural number defined by defined by image of x is equal to say x square. Then verify whether f is 1 1 as well as onto r0. Avutile check ಮಾಡಿ. Simple method. Take Venn diagram. F is a function from n to n. Okay? N is what? Set of natural numbers 1 2 3 4 5 6 7 and so on. Here also same number of elements, isn't it? 7 8 9 and so on. Now f of x. X is domain. X square is codomain. Take one by one. Put x equal to 1. X value 1. X square. 1 square is 1. Okay? Put x is 2. 2 square is 4. Put x is 3. 3 square is 9. Somewhere here. Put x is 4. 4 square 16. Somewhere is here. Is it 1 1? Yes. Clearly it is 1 1. Because image of element first set will have different elements, will have different images. One element, one image is there. Clearly it is 1 1 function. Is it onto function? No. Why? Because codomain is not equal to range. Range is only 1 4 9 16. Only square of the numbers is range, but remaining numbers is not range. So what is codomain? Codomain is set of all natural number. Is it set of all natural number is equal to range? No. Range value 1 4 9 16 25 like that. So codomain is not equal to range. No need 2 ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ 2 ಇಮೇಜ್ ಇದೆಯಾ? ಇಲ್ಲ. ಯಾಕಿಲ್ಲ ನೋಡಿ? 2 belongs to codomain. 2 codomain ಇದೆ. codomain ಏನಿದೆ? x square. x square is equal to 2 ಆದ್ರೆ what is domain? x value ಏನಾಗುತ್ತೆ? √2. Is it √2 is natural number? Does not belong to natural number. So that ಇದರ ಇಮೇಜ್ ಇಲ್ಲ. So 3 image ಇಲ್ಲ, 5 image ಇಲ್ಲ, 6 image ಇಲ್ಲ. So codomain is not equal to range, therefore it is not onto, but it is 1 1 function. Okay? Another example. If we take another example, f is a function from say same question. Instead of natural number r to r or z to z, set of integers to integers, defined by f of x equal to x square. Verify. Is it to 1 1 as well as onto or not? Check. F from z to z, set of integer to integer. What are the integers? 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 plus 4 minus 4 and so on. Here also same number 0 1 minus 1 plus 2 minus 2 plus 3 minus 3 plus 4 minus 4 and so on. Check it. This is x domain and x square is codomain. Take one by one. Put x is 0, 0 square is 0. Put x is 1, 1 square is 1. Put x is minus 1, minus 1 square is 1. Put x is 2, 2 square is 4. Put x is minus 2, minus 2 square is 4. Is it 1 1 function? No. Why? Because ಎರಡು ಎಲಿಮೆಂಟ್ ಒಂದು ಇಮೇಜ್ ಇದೆ, ಇರಬಾರ್ದು. 1 1 means ಒಂದು ಎಲಿಮೆಂಟ್ ಒಂದೇ ಇಮೇಜ್ ಇರಬೇಕು. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗಿದೆ? 2 elements ಒಂದೇ ಇಮೇಜ್ ಇರೋದ್ರಿಂದ that is not 1 1. It is many one function. Here clearly it is not 1 1 function because f of 1 value is 1 and f of minus 1 is also 1. So f of 1 value 1, f of minus 1 value 1, RHS is same. Therefore f of 1 is equal to f of minus 1. But 1 is equal to minus 1. No, 1 is not equal to minus 1. F of x1 equal to f of x2. Okay, but is it x1 equal to x2? No, therefore it is not 1 1 function. It is many one function. Okay, is it onto function? Onto the no. Why? Because if you take the number minus 1, definition of onto is for all the elements in the codomain. Codomain ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ವೆರಿಫೈ ಮಾಡಬೇಕು. ಆಗವಷ್ಟೇ ಅಲ್ಲ. If you take minus 1 belongs to codomain. Codomain is x square. See, x square value minus 1. What is domain? What is x value? X value is root of minus 1. Root of minus 1 is I. Is it belongs to real number? Is it belongs to integer? Does not belongs to integer. So is it integer? Minus 2 ತಗೊಂಡ್ರೆ image ಇದೆನಾ ಇಲ್ಲ? Then 3 ತಗೊಂಡ್ರೆ image ಇದೆನಾ ಇಲ್ಲ? Minus 3 ತಗೊಂಡ್ರೆ image ಇದೆನಾ ಇಲ್ಲ? So codomain is not equal to range. Therefore it is not onto. It is not 1 1. So remember, they will ask in final exam. F is a function from z to z. Defined by f of x is equal to x square. Verify whether the function f is 1 1 as well as onto or not. Clearly it is not 1 1. It is not onto. Why it is not 1 1? Because different elements of a set will have which is not different images in the second set, because f of 1 is equal to 1, f of minus 1 is also 1, therefore f of 1 is equal to f of minus 1, but 1 is not equal to minus 1. In general, f of x1 is equal to f of x2 implies x1 is not equal to x2. Actually x1 is equal to x2 but unequal agodilla. So it is not 1 1 as well as not onto. Why it is not onto? Because codomain is not equal to range, therefore it is not onto function. Clear friends? So remember, define onto function in general. A function f from a to b is said to be onto if in general for all the elements say y belongs to set b, there exists its image in the set a such that image of the function f of x equal to y, that y belongs to set b, that is known as onto function. Short form, codomain is equal to range, then it is said to be onto function. Codomain alliruttಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ ಮತ್ತು ಅದರ ರೇಂಜ್ ಅಂದ್ರೆ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಇಮೇಜಸ್ ಎಲ್ಲ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಆಗಿತ್ತು ಅಂದ್ರೆ it is said to be onto, otherwise it is not onto function. Clear students? Next definition, define type number 3, inverse function. Define inverse function. And before that, bijection. Third type is bijection. After that, inverse function. So type number 3, bijection. Bi means what? 2. Define bijection. Remember, very simple definition. That question was asked in previous year. 1 mark question in your question paper. Part A, first question. I think that question was asked in 19 or 18. Define bijective function. Bijection. Remember, a function f from a to b is said to be bijective function. Is said to be bijection or bijective if and only if it is both 1 1 and onto. ಎರಡು ಇರಬೇಕು ನೋಡಿ, 1 1 ಆಗಿರಬೇಕು, onto ಆಗಿರಬೇಕು. If it is both 1 1 and onto, then the function f from a to b is said to be bijective function. Now for example, using Venn diagram, look here, f is a function from a to b. Since a is a set consisting of 5 elements, a, b, c, d, e, b is a set consisting of again 5 elements, 1 2 3 4 5. Now image of a is 5, image of b is 4, image of c is 1, image of d is 3, image of e is 2. Now here f image of a, f of a is equal to 5, f of b is equal to 4, f of c is equal to 1, f of d is equal to 3, then f of e is equal to 2. Observe it, all the elements of the first set will have different images in the second set. 1 is to 1, one element in one image is there. Clearly it is 1 1 function. Is it onto function or not? Clearly it is onto, because what is domain? Domain is set A. What is codomain? Codomain is set B. Codomain is equal to set B. What is range? Range ಯಾವಾಗುತ್ತೆ? Range ಅಂದ್ರೆ ಏನು? ಎಲ್ಲಾ elements images satisfied ಆಗಿರ್ತಾನೆ. 1 2 3 4 5. That is nothing but B set. So codomain is equal to range. It is onto as well as it is 1 1. Therefore this example is bijective function. Bijective ಆಗಬೇಕಾದ್ರೆ 1 1 ಇರಬೇಕು, onto ಇರಬೇಕು. ಎರಡು satisfied ಆಗಿತ್ತು ಅಂದ್ರೆ it is said to be bijective function. ಅದೇ ಬಂತಲ್ಲ. Another example, if f is a function from set of real number to real number defined by f of x is equal to x2, verify whether the function f is bijective function or not. Now how to solve? Using Venn diagram. Either you can use Venn diagram or you can use another definition of 1 1 function as well as onto function. R to R, easy method. Take Venn diagram. R means set of all real numbers. All numbers are real numbers. Note that every natural number is real number, every integer is real number, every rational number is real number, every irrational number is real number. All numbers are real numbers except root of Then here also same number. 3 minus 3, 4 minus 4 and so on, or 5, or 6, take any number. Okay, now f of s, this is x, 4 is x cube, put x is 0, 0 cube is 0, 1 cube is 1, 2 cube is 8, somewhere here, right? So minus 2 cube, how much? Minus 8 here somewhere, then 3 cube 27, somewhere here, minus 3 cube minus 27, observe it. Is it 1 function? Yes, here it is 1 function. 1 yes, it is 1 because different elements will have different images. Is it onto function? Onto ಆಗುತ್ತೆ ನೋಡಿ? No, ಇದೆಲ್ಲ ಓದುತ್ತಿದೆ. ಇವೆಲ್ಲ numbers image ಸಹಿತ ನೋಡಿ ಇಲ್ಲ. Here codomain is not equal to range. How? You take one number, say minus 1 belongs to codomain x cube. X cube value is minus 1 r. What is x value? Cube root of minus 1. Cube root of minus 1 is 1 omega square. Cube root of minus 1 is 1 omega square. Omega value minus 1 plus root 3 I divided by 2. Is it belongs to real number? Does not belongs to real number. That is omega value root 3 I birthday. I it is complex number, but here real number. That is not real number, it is complex number. So its image is real now. So it is not onto. Take another number 2 to order. X cube is equal to 2 to order. X is equal to around the cube root of 2. Is it cube root of 2 is real number? Yes, 2 is real number. Cube root of 2 is there. Then minus 2 to order around the cube root of minus 2. Again root of minus 2. Negative value does not belong to real number. So codomain is not equal to range. Therefore it is not onto with only 1 function. So it is not bijective, it is only 1 function. So bijective agara both 1 and onto function. Eradu satisfied agittu andre it is said to be bijective function. So definition: define bijective function or define bijection. Remember, a function f from a to b is said to be bijective function or bijection if and only if it is both 1 as well as onto. 1 ಇರಬೇಕು, onto ಇರಬೇಕು. ಎರಡು satisfied ಆಗಿತ್ತು ಅಂದ್ರೆ it is said to be bijective function. Clear students? Okay. Next definition, that is type number 4, that is inverse function. Define inverse function. Very simple definition. Type number 4, inverse function. A function f from a to b. Since the function f from a to b, which is 1 and onto. ನೋಡಿ ಕೊಟ್ಟಿರತಕ್ಕಂತ ಫಂಕ್ಷನ್ ಏನಾಗಿರಬೇಕು? 1 ಇರಬೇಕು, onto ಇರಬೇಕು. ಎರಡು satisfied ಆಗಿರಬೇಕು. A function f from a to b which is 1 and onto, then the function from reverse, then the function from b to a. Now first by taking from left to right it is 1 and onto. By taking from right to left, reverse kondaga pura. Then the function from b to a which is also 1 and onto. Which is also 1 and onto. Remember, since f is a function from a to b which is 1 and onto, then the function from reverse from b to a again it is 1 and onto, then the function f is said to be inverse function. Then the function f is said to be inverse function and it is written as f inverse from b to a. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Since f is a function from a to b which is 1 and onto, then the function from b to a again it is 1 and onto, then the function f is said to be inverse function which is written as f inverse from b to a. Okay, now we are for example using Venn diagram. Since f is a function from a to b, a is a set consisting of 5 elements, b is a set consisting of again 5 elements. Now here image of a is 2, image of b is 1, image of c is 4, image of d is 5, image of t is 3. Now here image of a, f of a is equal to 2. Image of b, f of b is 1. Image of c value 4. Image of d is 5. Image of e value 3. Clearly different elements of a set will have different images in the second set. Clearly this one is it onto? Yes, because codomain is equal to range. All elements images satisfy like that. It is one and onto. Therefore it is bijective function. Then the function from reverse. Then the function from B to A. F inverse from B to A. Defined by from A to B we write f of A is 2, right? F of B is 1. Whereas function from B to A, f inverse from B to A defined by f inverse of 1 is equal to f inverse of 1 is B. F inverse of 2 is A. F inverse of 3, no inverse image of 3 is there, E. F inverse of 4, that is C. F inverse of 5, that is D. Read it as inverse image of 1 is B, inverse image of 2 is A, inverse image of 3 is E, inverse image of 4 is C, inverse image of 5 is D. Okay, again it is 1 and 2. Is it 1 and 2 or not? Yes, obviously it is true. So, in this example, F inverse from B to A defined by inverse image of 1 is equal to B. Read it as inverse image of 2 is A, inverse image of 3 is E, inverse image of 4 is C, inverse image of 5 is D. Okay, so this is also 1 and 2. Reverse tone ಏನಾಗಿರಬೇಕು 1 and 2 into ಅಂದ್ರೆ then the function f is said to be inverse function or another name is invertible function. Either inverse function or invertible function. Now invertible function it is 1 as well as on 2. Then the function from reverse from function from B to A, again it is 1 and on 2. Then the function f is said to be inverse function. Yes. Now inverse function, I will repeat once again. Since f is a function from A to B, which is 1 and on 2, then the function from reverse from B to A, which is also 1 and on 2, then the function f is said to be inverse function or invertible function. Take one particular example. F is a function from A to B defined by A is a set consisting of 5 elements, B is a set consisting of 5 elements. Here image of A is 2, image of B is 1, image of C is 4, image of D is 5, image of D is 3. All the elements will have different images in the set B. Here it is 1 as well as on 2 because codomain is equal to range. All elements satisfied ಆಗಿದ್ದವು codomain is equal to range. Therefore it is 1 and on 2, that is bijective function. Then the function from reverse, function from B to A, ಈ ಕಡೆಯಿಂದ ತಗೊಂಡಾಗ from right to left, f inverse from B to A is defined by f inverse of 1. Read it as inverse image of 1 is B, inverse image of 2 is A, inverse image of 3 is E, inverse image of 4 is C, inverse image of 5 is D. Again it is 1 and 2. Then the function f is said to be inverse function or invertible function. Remember here inverse image of 1 is B implies what is image of B? F for F inverse is equal to what? F of B is equal to what? 1. Image of B is 1. F inverse of A is equal to 2. F inverse of 2 is A implies image of A is equal to 2. Inverse image of 3 is E implies image of E is equal to 3. Inverse image of 4 is C implies image of C is equal to 4. Inverse image of 5 is D implies image of D is equal to 5. Okay, so remember, since f is a function from A to B which is 1 and on 2, then the function from reverse B to A, again it is 1 and on 2, then the function f is said to be inverse function or another name is invertible function. Okay students, then last type, that is composite function. Define composite function. The composite function is nothing but just like this transitive relation. You know the definition of transitive relation. What is that? If that is a relation R in a set A is said to be transitive if AB belongs to R, BC belongs to R, B vanish, AC belongs to R. Same concept here. Define composite function. Last time, define composite function. Remember that f is a function from A to B and g be a function from B to C. Consider two functions namely f and g are two functions. Then f is a function from A to B and g is a function from B to C, be two functions. Then the function from A to C, just a transitive relation, AB, BC, B vanish, A to C. Then the function from A to C is called F composition G. F composition G. याके A set क्या function होगी F function होगी from function from A to C, that is known as F composition G, and it is denoted by like this. Read it as F composition G. Don't read GOF, not GOF, not GOF. F, that notation indicate composition G. Why we write like this? Because first you have to operate by the function F, then operate by the function G. So function from A to C is called F composition G. Okay. Whereas the function from C to A to then the function from C to A, C ಯಾವ function ಅಲ್ಲಿ G ಒಳಗೆ. Now the function from C to A, that is known as G composition F, and it is denoted by first write G, backside composition notation F. Why? Because first you have to operate by the function G and then operate by the function F. This is F composition G from C to A. Okay. Now by using that diagram, look here. Take three sets. Say A, B, C are three sets. A set, B set, C set. F is a function from A to B. G is a function from B to C. In the set A contains one element, say X. Set B contains only one element, say 1. And set C contains one element, say Z. Now image of X is 1. F of X equal to 1. That is y is equal to F of X. Image of X is 1. Then image of y is Z. Image of y is G of y is equal to Z. Then the function from A to C, that is F composition G from A to C. Then the function from A to C is called F composition G. That is Z is equal to G of y. What is my value? F of X. This is known as F composition G. First you have to operate by the function F. After that operate by G. Whereas G composition F means first you have to operate by G composition F is same as first you have to operate by the function G and then operate by the function F. Okay. Image of X is y. Image of y is Z. That Z is equal to G of y. That is G of y value F of X. This is known as F composition G. So define composite function. If now that F is a function from A to B and G is a function from B to C, B two functions, then the function from A to C is called F composition G. Read it as F composition G. Why we write like this? First you have to operate by the function F, then operate by G. Read it as F composition G. Don't read GOF, don't read FOG, not FOG, not GOF. This is F composition G, that is G composition F. Okay, so these are the 5 important types of functions. So namely one function ಹೇಗಿರಬೇಕು, one element ಗೆ one image ಇರಬೇಕು. Image of x1 is equal to image of x2 implies x1 is equal to x2. Then the function F is said to be one function. One element ಗೆ one image ಇರಬೇಕು. One ಆ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಇದೆ. One made for each other. One element will have one image. Okay. Onto function ಆಗ್ತಾರೆ 4 domain is equal to range. Mathematically y is equal to f of x or f of x is equal to y. 4 domain is equal to y is 4 domain. 4 domain is equal to range. Then it is said to be be onto function. If this condition is satisfied, it is said to be onto function. Onto our codomain is equal to range. Type number 3, bijective function. A function f from a to b is said to be bijective if and only if it is both 1 as well as onto. Where satisfy it is said to be bijective function. Then define type number 4, inverse function or invertible function. Since f is a function from a to b which is 1 and onto, ಕೊಟ್ಟಂತ function 1 onto ಇರಬೇಕು. Then reverse ತಗೊಂಡಾಗ ಕೂಡ then the function from b to a again it is 1 and onto. Then the function f is said to be inverse function which is written as f inverse from b to a. F from a to b which is 1 and onto, then reverse the function from b to a that is known as inverse function denoted by f inverse from b to a. Okay, the reverse ತಗೊಂಡಾಗ ಕೂಡ ಏನಾಗಿರಬೇಕು, it is 1 and onto. Then finally composite function. F is a function from a to b, g be a function from b to c, be two functions. Then the function from a to c is called f composition g, denoted by like this, f composition g from a to c. Now here f composition g, it means first you have to operate by the function f, then operate by g. Then the function from c to a, that is known as g composition f, which is written as g. This is notation for composition, then f. It means first you have to operate by the function g and then operate by the function f. So these are the 5 important different types of functions. Based on these 5 types, to solve some problems in next class. Okay students, thank you.